Welcome to Reliability Matters, a podcast for the electronic assembly industry. Each episode covers topics related to reliability, best practices, and environmentally responsible assembly techniques, with insights from experts across the electronic assembly industry. Now, here's your host, Mike Conrad.
Dr. and Professor Ron Lasky, Raaga Kannan, and Nadia Clement, thank you for all being my guests today. And the mysterious person who's not moving, Annaka Balch, is also with us in spirit. We hope that she'll be joining us in person in just a little bit. She had a meeting that is running long, as Zoom-type meetings do, and we hope that she'll jump in when she's done with her meeting, and when she does, we'll put her in the screen here. But for the moment, we have her likeness on our screen, her avatar. So welcome all of you. Thank you for being my guest today on Reliability Matters. Dr. Lasky, can you, more formally and in a more in-depth manner, introduce your students?
Sure. Well, I'm a professor of engineering at Dartmouth College, and Nadia and Raaga and Annaka co-authored papers with me at the 2020 PANPAC on the Big Island in Hawaii. And I talked to Mike a little bit about, maybe it'd be interesting for his viewers to understand a little bit about that, because I think it is something that's maybe unique. So I wanted to give some papers at PANPAC, and I wanted to see if some students would be involved. So Raaga and Nadia and Annaka all co-authored papers with me, all on different topics. And Dartmouth was very helpful that they allow undergraduate students, which they are, to go to conferences, and they pay for some of it. So pretty much they were able to go with very minimal expenses on their own.
Excellent. And gave papers. Let's talk just for a few minutes about the papers that were given. One thing I love about PANPAC, it's not your traditional technical symposium. It's not subject matter based. Or some are. You go harsh environment conference, cleaning and coating conference, voiding conference, additives conference, where you have a very narrow subject matter. But in this case, it's very eclectic. There's quite a bit of technical material, obviously, so that doesn't disappoint. But there's also, one of our keynotes was an astronomer on the island and talked about his findings and things like that. It's a very interesting symposium. Even though they call it a microelectronics symposium, there's way more than microelectronics involved. But if you're going there for microelectronics, you won't be disappointed. Let's walk through some of the papers. Nadia, let's start with the paper that you gave. And of course, we're going to take you off the hook. We're not asking for your entire presentation over again. You've been there, you've done that. But I did find all the papers very interesting. Tell us what your paper was titled and kind of from a press box view, what it was about.
Yeah, thank you for having us again. So my paper was called Weibull Distribution and Analysis, and so it was co-written with Dr. Ron, as he mentioned. And basically it was kind of a Weibull Analysis 101 type paper. So we discussed what Weibull analysis is and how it can be used to do reliability analysis, survival analysis, and yeah, so we went through how to measure, and make probability plots for failures for solder, and the different types of materials that are used. And then we also went through, in the end, how to do the analysis in a program called Minitab. So that was my paper.
For our audience. Oh yes, please, Dr. Ron.
This really took me off the hook a bit, because what I did is I have a lecture on Weibull analysis, and I was kind of lazy, so I asked Nadia if I gave her the PowerPoint slides and she could see the video of me lecturing. It's about a 45-minute lecture. Could she write the paper? So it helped me, because I was kind of busy, and she essentially wrote the whole paper herself without me. Of course, the background material was from my slides, but it was still really, really helpful because it isn't necessarily simple to take a PowerPoint presentation and turn it into a paper. And I really didn't have to edit it at all. So it was really helpful to me. And I think a good experience for her.
Yeah, excellent. Raaga, tell us about your paper.
Sure. So I was able to co-author a paper with Dr. Ron on autonomous vehicles. Dr. Ron basically brought me into his office and was like, Raaga, it's 2019. Do you think there's going to be a fleet of robo-taxis on the road next year? He's like, I don't think so. So I was able to research about what the current systems in place are, like the ADAS systems, such as your like cruise control or advanced adaptive cruise control and those systems, and see what the process of going from the systems in place to a fully autonomous vehicle entails and what technology is needed. And so we're specifically focusing on artificial intelligence and whether the current artificial intelligence meets the standards that are necessary to produce fully autonomous vehicles. So that was really exciting to research about, see what technology is currently in place, what kind of like precision is required for these systems, and the testing standards that are needed to get these on the road.
This is one of my favorite subjects, is the whole concept of autonomous cars, because I'm into reliability, hence the name of the show, Reliability Matters. And as cars become more electrified, as they become more computerized, unlike the so-called old days when we started putting computers in cars, they were for infotainment. They were for seat massagers or seat heaters or satellite radio and things like that. And if they failed, arguably first world problems, right? My back is sore because my seat massager broke and I couldn't program it. Now with adaptive cruise control and automatic lane correction and rear and front collision avoidance and blind spot indicators and all that. If any of those things fail, we can get seriously hurt or worse. And I like to, in my other shows, I've talked about the fact that I've become a worse driver today. I consider myself a really good driver. I sound like Rain Man. I like to drive. I really like to drive. And when I had my first car with all of this modern safety stuff, I didn't trust it. So the adaptive cruise control, I would speed up on slowing traffic, and my foot would be right there over the brake, just in case the computer didn't get it, and I was a nervous passenger to all this computer-aided driving. And my blind spot indicator, I would see something flashing or not, and I would still look over my shoulder because I didn't trust the system. And same with, reversing and automatic parallel parking. My hands were there ready to take over. Now I fully trust those systems. And now I don't look over my shoulder. I trust my blind spot indicator. I don't put my foot over the brake ready to intervene. I trust that it will see the traffic slowing and slow down, and all sorts of examples like that. So now if something does fail, I'm not ready to take over, right? So I've kind of put my safety into the hands of these systems. And unlike airplanes... No, go ahead, Raaga.
I was just going to say, I think there was a quote I put in the paper from Stephen Shaldover, and he says, imagine if your car froze as many times as your laptop or phone. And that's kind of an example of what precision of software is required so that you can trust this car to do the driving for you.
Sure. And in the aviation world, with autopilots and auto throttles and all these different things in the cockpit, we've had automation for years in the cockpit. However, there is one primary computer and two backup computers for every safety system on there. So, if one fails, there's two backups. And that's not the case in the auto industry. We're not selling automobiles for $300 million, that we would sell a 777 for. So, a whole different world with automation within the automotive industry. And I think one of the things that, well, you tell me, what's holding back the fully autonomous, what do they call that, level 5 or whatever the top number is? What are they?
Yeah, level 4 and level 5.
4 and level 5.
So the main thing is current vehicle designs could probably drive on their own, entering the highway, exiting the highway. But what the main issue is like pedestrians. So not only does the car have to do the driving, but they also have to perceive the actions of pedestrians, other cars on the road. So it's all those traffic intersections, like roundabouts where you look over at the person to signal you're going to enter. Those kind of little actions that we do naturally from years of experience is really hard to teach a car. So you're basically just running simulation after simulation through the car to teach it the stuff through machine learning. But the amount of edge cases you need to account for is very difficult.
Right.
So I think that's probably the main issue that's holding it back.
I have a few more.
Let me chime in a little bit too.
Yes.
Since we wrote this paper, I've become more of a skeptic. By what I mean by that is, just as Raaga said, even like 5 years ago, Tesla, I think, had systems that we live north of Logan Airport in Boston by about 2.5 hours. And if you get on the main highways, it can do that pretty well. But the last 5% that you need to be able to do is going to take years and years if it will ever be achieved. And a lot of it has to do with what humans would call common sense. What if there's a detour? What if there's a detour and you have to roll your window down and talk to a policeman? Or as somebody pointed out, you're driving in town and you see a bunch of people at the corner and you look at them and you can tell by their actions, if they're just talking and look at each other, they're not going to cross the street. But if they're looking like they might want to cross the street, a human can read that pretty quickly, and it's really, really difficult for computers. Anything that we call common sense for computers is not common.
Right. That doesn't fall into binary. That doesn't fall into 1 or 0. It's like 1.5, 0.5. It's.
I remember about 4 or 5 years ago, people were saying, if you're a young person, don't become a truck driver because you won't have a career in 10 years. There certainly there will be trucks that will be driving part of the way. And maybe instead of 2 drivers, they'll have 1. But I just don't think, even in 20 or 30 years, that there'll be cars and vehicles that can completely drive by themselves because of these. The last 5% is really, really hard.
Well, there's a reason why young people pay more in insurance, because statistically younger drivers get into more accidents. And I don't think it's because they don't know how to drive. I think it's because there's no experience, exactly to your point, at the corner, looking in someone's eyes or seeing their eyes in their rearview mirror, in front of you, and predicting what they're going to do. By the time you've driven it for as many years as we have, right, Professor, and me, we,
not Raaga.
We practically, had to crank start our cars, practically speaking, and we can predict what other drivers are going to do, and I'll be driving with my wife, and I'll go, that person's going to do this. And she goes, how do you know? I'm like, there they go. You just get in tune. And you're right. Computers, I think the delay in fully autonomous top level driving is humans. It can't predict what humans will do. Computers can predict the predictable. It's very difficult for a computer to predict the unpredictable, because how do you factor that in? It's going to, if you program a computer to predict unpredictable things, it's going to be paranoid. It's going to call all these false predictions, right? Because it could happen, not because it's likely to happen.
One of the things that's related to this, not exactly the same, but I think it shows us where artificial intelligence is. Artificial intelligence can do very focused tasks very well, but Steven Pinker, an author, pointed out that no artificial intelligence connected to a robot can empty a dishwasher. And when my grandson was 5, I think I could show him how to empty a dishwasher and he could figure it out. And it's not that we can't do that today. People that study this don't think we'll be able to do it in 10 or 20 years. It's just the things that are often easiest for humans, the common sense things, are really, really hard for computers.
Right.
And artificial intelligence.
Right, exactly. Nadia, I want to go back to you. I realize there's probably some people listening to this podcast or watching this podcast, and we lost them at the word Weeble. So let's go back and tell me what, or Weibel, tell me what that type of analysis is compared to maybe other types. What makes that particular technology stand out?
Yeah. All right. So in using Weibel analysis, you basically, let's see. So if you have, failure rates, let's see, maybe if we go down to page 3, there's a couple. Yeah, there we go. So if you see these different types of failure patterns have different shapes in sort of a regular plot. So you would see early, infant mortality failure. There would be, a lot more in the early time, and then wear out failures would happen in the end, and then sort of random failures are happening all across. And so you get this bathtub shaped curve. But with Weibull plots, you can see more of a sort of linear pattern. And then with that, you can see outliers as well. And so, if you go down a little bit, we can see
a Weibull plot.
That. Yeah. Yes. Yeah. Dr. Ron, did you have? Yeah.
No, I was just going to say to show that.
Yeah. So that's, one of the main benefits. And so then if we go down to page 4, right there, you can see when there are multiple failure modes, that can become clearer in a Weibull analysis. So there we can see there are kind of 2 outliers at the beginning, and then a different straight line after, and that's
probably 2 different
really
failure
helpful.
modes.
Yes, yeah.
You couldn't see that with just a standard plot. You'd have to have a Weibull plot to see that.
And are there particular types of analyses that are more suitable for a Weibull diagram or a Weibull plot than others? Are there, or the inverse? Are there certain types of analysis that just don't fit into that type of structure?
Can I chime in a little bit?
Please.
Yeah.
So Weibull got this idea in like the 30s, and he proposed it to plot fails in with Weibull analysis. So often you get a straight line, and of course you'd think everybody would have loved it initially, but it really any new thing, it's hard for it to be accepted. But what he showed is that failures of almost any type often will fit the Weibull curve, and he showed this way beyond just electronics. But now in electronics, it's almost too well accepted. It's almost like a religion, and some people will just do the plots and say, here's the plot, and you get 2 constants from the plot, eta and beta, and instead of seeing that the plot is telling them a lot more than just doing the Weibull analysis with a computer. And as could we go back to Nadia's paper?
Sure.
So in a paper, that's actual real data that people just, if you see to the right, you see the Weibull equation, and you're able to solve for eta and beta when you plot it out like that. And it gives the best fit as you see the line in the center. But what the people fail to recognize, as Nadia pointed out, that the first 2 points have a different failure mode. They're separate from the other points. And that's one of the things we pointed out in the paper, that you don't just use a computer to calculate eta and beta. When you see something like this, notice that there are 2 different failure modes.
Interesting. So Weibull came out named after the person who
Elodie Weibull. Yeah.
Yes, yeah. That was in the 30s, sometime 1930s. Sometime?
He proposed it in the 30s, but it wasn't really accepted until like the 50s. And it's almost always this way. I mean, when Einstein came out with his theory of relativity, everybody said he was crazy.
Sure. And
now it's really well respected. And it's the same thing with Weibull analysis. It's now the end all and be all. And obviously, you wrote the paper. I do think it's important. But what I find almost everybody does, that I just showed, is they'll just take the data, put it in a computer, and get the eta and beta, and not look and see that there might be multiple failure modes.
I was going to ask about that. I was going to ask, have Minitab, which is an example of an app that can crunch those numbers.
Yeah.
How much have computers taken away the nuances of a Weibull analysis?
I think it's a lot, and I think it goes way beyond Weibull analysis. I don't want to spend too much time on this, but when Weibull analysis was done before computers, you had to do it by hand, and so you would painstakingly plot those two points that were from a different failure mode, and it sort of becomes part of you because you spent a lot of time doing it. And I find as a professor that engineering students today aren't quite as good at sometimes analyzing data as their father or grandfather might be, because especially their grandfather probably did it with slide rule and it took hours, where today you just put the numbers in and press a button, it's done in 15 seconds. So I find often I have to work with my students to kind of step back and really look at what the plot is telling you a story. Don't just instantly get some numbers and write them down from the computer and say that's it. Look at the data and think about it.
Right. That makes a lot of sense. Let's speak virtually or channel our friend Annaka, if you wouldn't mind.
Yeah, I can talk about her paper, I think.
Okay. All right. Super.
Okay. So these three papers were presented at the 2020 SMTA PanPAC, and Annaka actually went with me to the 2019 PanPAC. She helped me author a paper on tin whiskers 101. And while we were there, the president of INEMI was there, and I asked the question, has anyone ever looked at the roadmaps that were proposed, the earliest going back 25 years ago, and seeing if the roadmaps predicted what really happened? And the people from INEMI said, not really. So I talked to Annaka about it, and I said, would you be willing to, for a senior project, analyze some of the past roadmaps and look at what really happened and see did it mate? And so INEMI gave Annaka access to all of their roadmaps, and she focused on a few areas. And to tell you the truth, I was pretty surprised. A lot of the prediction actually did end up coming true. Of course, some of them didn't, but I thought all in all, it was pretty supportive of road mapping as something that's helpful to do. So what the people said would happen in 1996, most of it did. Not all of it, but most of it. And so Annaka presented that paper, and it was the people that evaluated the papers considered it the second best paper at the conference. So
yeah,
I thought for an undergraduate that was pretty impressive.
I'll read her conclusion.
I should say, by the way, what the conclusion was that I think in about 70% of the cases that the roadmap predictions came true.
Yeah, I'll read her conclusion. It's quite interesting because it should not have been all that accurate, because it's difficult to predict technology which isn't around, right? And new regulations and things like that. But she said INEMI has made many projections over the last century, a majority of them very accurate, with all the advancements in new legislation, to the point we were just making. Many would expect otherwise. Conversion costs and MPI cycles were all estimated very accurately, which is amazing because this industry changes at the speed of light. Even it was estimated to be very accurate even 15 years out in 1995. So much has changed. We're in this not revolution, but evolutionary time where everything we have had for the last 30 years, we still have, but they're half the size, twice as fast, half the cost. They're just, everything's evolutionizing at a record pace. The area with the most discrepancies, she points out, was in component trends, where in 1994 and 2002, roadmaps were largely overestimated the component density capabilities. So it's hard to imagine we can overestimate component density because now I can't even see components. Wearing glasses doesn't help anymore. If you drop them, just forget it. I mean, they're going to end up in the soles of your shoes forever. But it was interesting to see the analysis as being largely accurate on something that would be so difficult to predict, like the electronics industry.
Sure. I gave credit to Dartmouth for paying to send the students, but I should also give credit to Indium Corporation, in addition to being a professor at Dartmouth. For almost 20 years now, I've been a work for them part-time as a senior technologist. And so they paid for my time to write the papers and go to the conference, and paid for me to go to the conference. So Indium Corporation and Dartmouth College supported this. And I sort of encourage some of my professor friends to consider doing the same thing, because what a win for everybody. It took a lot of pressure off me, because Raaga and Nadia and Annaka are outstanding writers. So I really didn't have to, after they wrote the papers, I really didn't have to edit them hardly at all. And so it was a win for me, because I was able to do more, and a win for them, because I think an experience like this is hard to say how much benefit there is for a student to go to something like this.
Yeah.
And it was kind of fun being in Hawaii in February. I think
it ain't bad. It ain't bad. When my daughter was younger, she would have said, "That doesn't suck." Yeah, there are worse places to be. And I'm hugely looking forward to the 2022 PanPAC for a number of reasons. I live in Southern California, so I don't go to Hawaii for the weather. Our weather's not so bad here. But, the first major excursion, work trip out of this pandemic to be Hawaii is not bad.
Yeah.
It's not bad.
Yeah.
And I think
maybe I can mention a little bit what we're hoping that they're going to present is I have struggled to understand quantum computing. And the committee, I'm on the organizing committee for the next conference, and all the people on the committee agreed, wouldn't it be really great if we would have a keynote speaker on quantum computing, and maybe a paper on quantum computing 101. So you are in the presence of two young gals that are working with a professor at Dartmouth to prepare this quantum computing 101, so all of us can understand how it works. And the professor at Dartmouth is also giving the keynote talk. So that's what we plan. That's what we plan.
Well, I have to admit, I'm one of the parts of the masses that really understands the phrase, but doesn't really understand beyond the phrase of quantum physics and quantum computing. So are quantum computing a derivative of quantum physics, or
it is. It is. But what I can't understand is, supposedly the quantum computers, even the ones that exist today, which are really primitive, there's something called quantum supremacy, which means a quantum computer can solve a problem that a traditional supercomputer would take maybe 200,000 years to solve, and a quantum computer can solve it in a day. And I just don't understand how it can be that much faster. And that's certainly one of the questions I would have in the quantum computing 101. So there's another thing I don't understand that we're not going to discuss. I still can't understand Bitcoin. So, Mike, when we're at the conference, maybe you can explain it to me.
We'll do a whole thing on cryptocurrency.
I just don't understand. What is it you get when you buy a Bitcoin?
Yeah, I know. I'm the same way. I don't know. Exactly what triggers its value. It's kind of like stocks. It's just it's supply and demand.
What is Bitcoin mining, and how is it that there can only be so many Bitcoins mined, and yet there are other cryptocurrencies? But that's a question for another day.
Now there's what Dogcoin? That's the latest trend in crypto. And I know these Bitcoin mining and cryptocurrency mining operations. There's a measurable amount of energy sucked up off the grid, running all these computers, 24 hours a day, and keeping them cool, and in hopes that they stumble across a Bitcoin.
Well, I read that China is thinking of really getting into this in a big way, and people in the article said it will require so much electricity that it'll impact global warming. So that's got to be a pretty significant electricity.
Right. Well, when Bitcoins were worth $8, I don't think there was a whole lot of mining going on. But now, I also admit I understand the concept of cryptocurrencies. Ask me how it works, no clue. Other than I know they live in a computer somewhere, and they're hyper secure, and
blockchain is an important part of it.
And blockchain is an important part of it, and blockchain has applications outside of cryptocurrency. So let's get a speaker. That's your challenge. Bring a speaker
by their
that.
reaction, I think Raaga and Nadia actually understand it all. Maybe I'll have to see, and they can present a paper on that.
We'll get to Hawaii 2 days earlier. We'll sit by the pool with our Mai Tais, and you guys can educate us on the ins and outs of cryptocurrency. There are worse places to learn. So, Raaga and Nadia, you've you've been involved in the electronic assembly industry through your education, your participation at PanPAC, writing these papers, working with Dr. Ron. I know you both broke my heart because earlier when we were prepping for the show, and you said you're not immediately planning on entering this industry, but I have my hopes that our industry will get our hands on you and eventually you'll come in. What direction are you taking, particularly with all this knowledge and experience through your education about things that affect our industry? What direction are you going to go? Let's start with Raaga.
Yeah, I'm a engineering and economics major, so I'm actually taking a finance route and I'm doing investment banking in biotech. So that's where I'm starting off next year. But yeah, we'll see after that. Maybe I'll come back into the electrical engineering world, and yeah, unsure.
So your undergrad is electrical engineering?
It's Dartmouth has a general liberal arts engineering sciences major, so I've touched upon everything from like mechanical to electrical.
Very well-rounded engineering.
Yeah,
that's good.
It's definitely a great experience.
Go ahead.
Oh, sorry. No, I was just saying
it's
definitely a nice format for the engineering program, and something you don't really find in a lot of schools where you immediately specialize into like chemical engineering per se, because you really get to see how they all interconnect, and I've enjoyed it because of that.
Very good.
Before we ask Nadia what she's going to do, so it will make sense to you, I need to take a step back. Annaka and Nadia are local to Dartmouth, and they were both high school students. I think Annaka's a year older, and I think she was number one in her class at Thetford Academy, and I think Nadia was number one in her class a year later. And I taught a course in the summer intended for non-engineers. It's called Materials, the Substance of Civilization. And it covers like Stone Age, Copper Age, Bronze Age, Iron Age, and today maybe the Silicon Age. And I needed some teaching assistants. So when they were juniors in high school, they became teaching assistants for me for a couple of years. And so I got to know them. And Nadia is really good at math. And so I thought she was going to be an engineer or a math major. But as time went on, she can tell you what she's majoring in. But when I wanted to write the paper on Weibull analysis, I said, well, to myself, even though she's not majoring in engineering right now, she's good at mathematics, so she should be able to write the paper. So that's why I recruited her, even though she's not an engineering student. So Nadia, why don't you tell us what you're going to do now?
Yeah, so I did originally think I was going to do an econ major with a math minor. That was kind of my original plan. I have still never taken an engineering course, which is interesting, but I have TA'd some. But so my majors are anthropology and linguistics. And so, yeah, pretty removed in most ways from the electronics industry, but I love it. I mean, linguistics especially is just definitely my passion. I love it so much, and I'll be taking a year after I graduate this spring off, just doing different things, but then I'll be going to grad school for a PhD in linguistics. That's my plan right now. So I'll be applying to grad schools this year. But yeah, so specifically historical and theoretical linguistics. That's kind of the...
Actually sounds very interesting.
She's too modest to say this, but you tell me if I get anything wrong on this, Nadia. She is born into a family that is monolingual in English, and she's proficient in every Romance language but Romanian. Is that right?
Yes. Wow. Yeah.
So Italian, French, Spanish, and Portuguese, right?
Wow.
Yes. Yeah.
The old joke, I'm sure you've heard this many times. My daughter would be rolling her eyes because she considers it in the category of dad jokes. But it's the name for someone who speaks 3 languages is trilingual, 2 languages, bilingual, 1 language, American.
Yeah.
So I do have a lot of respect for people who learn other languages. My parents were immigrants. My mother from Scotland, so obviously English, although one can say we're separated by a common language, with the accent and the slang. And my father immigrated from Poland. And so he learned English kind of on the road. and never spoke Polish at home. I always regret that he didn't teach us Polish, although in Southern California, it's not a very handy language. Spanish would be a more convenient, more practical language to learn. But I just always regretted that he never taught us something, because we lost the opportunity. He could have, when you're a child, I mean, your brain is very moldable. You can learn those languages much more easily as a child than you can as an adult. But
for me, my father spoke Slovak. Lasky is a Slovak name, and but he never thought to speak it. My mother was not Slovak, so he never spoke it, and so I never learned it.
Well, my dad was one of the generations of in the 50s that came over, and America's our new home. We're going to speak English and English, leave the old country behind. There was not this attitude of embracing your culture, and like we have today. Sure. But so Nadia and Raaga, tell me about your perceptions, and we'll kind of wrap up with this on the electronic assembly industry. What are your perceptions? I know you're not taking the route directly. We'll get you later. But what are your perceptions of this industry? What can, in your view, what can it do better? What is it doing well? What are the challenges coming up as you see it from your perch in your corner of the world through academia and through the experience you've had working with Dr. Ron and others and mingling with some of the players in this business at PanPac and any other events you've been to? Anyone can start.
That's kind of a tall question.
Yeah, it's a tall question. It's just your perceptions. I mean, there's no right or wrong answer. I'm just curious for someone that's educated and has dabbled in our industry, at least from witnessing point of view. What are your perceptions?
I can help maybe jog your memory a little bit.
There you go.
What did you think about the ratio of men to women and young people to old people at the conference? There weren't very many women, right? There were some, but there was hardly anybody your age. Yeah. And that's one of the things we worry about. We don't have young people coming that are going to replace people like me in 15 or 20 years.
Yeah, we were talking about that pre-show. We got on that subject that it always warms my heart when I see someone young and particularly female, and not to drive gender in this age where people don't like to talk about gender. I do think we need more women. We need more young people in this industry. It's just a bunch of old white men, for the most part, in our industry, and I think that needs to change, and we need to be challenged to look at things differently. And if it's just the same old guys going to every symposium, giving every paper, we're not going to think differently. We're going to just maybe think a little faster. We'll innovate to some degree, but we won't have that completely out of the ballpark revolutionary idea. We'll just evolutionize forever. We won't revolutionize. And we need people from outside our industry. We need fresh blood, fresh ideas, and not someone who remembers, we tried that and it didn't work, right? Because that's my generation. Yeah, we tried that, it didn't work. Mm-hmm. I turned my company over to my team. My team is substantially younger than me, and they run the company. And it scared me to death to do that, because there you want to try things that I've tried before, and I know they won't work. And then all of a sudden they try them and they do work. They just come from a different perspective. They don't know what they don't know, which is this sense of naivety, which is a compliment. It's an attribute to be naive. And I think Steve Jobs said I think at Stanford at a commencement address, stay hungry, keep learning. And so anyway, what do you guys think of this?
I think from a student perspective too, it's definitely more difficult to access this industry when you don't have female mentors. At least at Dartmouth, mentorship is something that's been very key for me throughout the years. And it'd be definitely nice if there were more female executives in those roles reaching out and speaking with people our age about the electronic industry and what opportunities there are for people like me and Nadia.
Raaga, can you mention how many females there are in your engineering class? Isn't it 40% or close to 50% female?
Well, Dartmouth, I think, is pretty special. I think actually the year that I entered, they graduated more females than males from the engineering
engineering.
school. And I think that's partially because of the liberal arts approach to engineering, and my engineering mentor actually, right when I came into Dartmouth, my mentor was a female engineering professor, which was really nice to have. Same with my physics professor. So I think, overall, depends on the courses, but the proportion is usually under 50%, but I do think it's been better at Dartmouth.
Yeah, and I do think, I had a lot of friends from high school, male friends who went on to do engineering at different schools, and they have said that it's still very, very male dominated at their schools. Like, I know this one boy that I went to high school with, he went to UVA, and just because of the history, the engineering building still only has male bathrooms still, which is crazy.
Wow.
That's crazy. I agree.
So yeah, it's I think Dartmouth is a really special place in that way that, there are so many women in STEM in general and in engineering in particular, for sure.
Yeah, Dr. Ron.
Let me mention a little bit about Indium Corporation in this regard. Indium Corporation does have a lot of young engineers, and I just had a Zoom call today with a female engineer that's been there just 6 months or 9 months, and it looks like we're going to write a paper together for SMTA. So I'm trying to encourage the younger people I know that are in the industry to get involved, and I think I'm going to try to figure out a way to see if I can get some of the young engineers from Indium Corporation at PanPac 2020 too.
Yeah.
Also.
Yeah, I had Indium's Kay Parker on my show. Early guest. Yeah. I contacted Rick Short, and I said, give me a name of, I want to bring one of your engineers on the show, talk about solder paste, and give me a name of someone or several people who would be good candidates. And she was among the list of about 8 or 9 people. So very interesting conversation. I do admire Indium a lot in that their approach to marketing is education based, as opposed to buy my product, it's in a shiny can, it's better than everyone else's, and whatever. Their approach to selling consumable products is to educate customers, and I find that that's how we do it in our company. We sell through education, because educated people make educated choices, and and I think that's a way to do it, particularly these days. I really appreciate all of you being on the show. Annaka, we missed you, but you were well represented by Dr. Ron. And I hope that we'll see all of you in sunny, warm Hawaii in 8 or 9 months.
Yeah. Honolulu this time.
Honolulu. I was glad about that, because I like a little bit of
and the resort
life.
is just off of Waikiki Beach, so it's a little more private. But I think you can get to Waikiki Beach in like 5 minutes. So
yes,
it should be really nice.
Yeah.
Nice.
Yeah. There's no bad place to do this on,
Oh, no.
any of those
Really
islands,
not.
right? There's really there's better and even better. But but I'm glad that it's on in Honolulu. I think that's wonderful. That's my favorite of the islands, because I love the resort atmosphere. Sit by a pool, feel like you're the only person on earth. But I also like to step out and have nightlife choices and things like that. So you get a little bit of both. My experience with Maui.
And beautiful nature. Absolutely. Maui is absolutely beautiful. The problem is Maui goes to bed at 8 o'clock. And the whole island just kind of goes to bed at 8 o'clock. And I'm still wide awake wanting to, be friends with people. So it's nice to go to Honolulu. That'll be really good. Dr. Ron, thanks for all you do. Thanks for
thank you.
coming up with this idea. I really appreciate it. And Raaga and Nadia and virtual Annaka, thank you so much for being my guest today. I don't think I need to wish you any luck. I think you are already on that trajectory. So I wish you all the best in your career. And I do hope that we see you in our industry at some point. I think we could definitely benefit from your expertise and all of your knowledge. So I hope we do get to see you for purely selfish reasons in our industry, but good for the linguists of the world, and good for the investment bankers of the world, and our loss, their gain.
Yeah, and Nadia and I
you.
and Annaka, Yeah, thank you so much. And we also wanted to thank Dr. Ron for giving us this opportunity in the first place to co-author this paper and go to Hawaii. We really appreciate it. And I think he was one of the few professors who really exposed us to this world. So thank you.
Yeah, thank you.
You're welcome. Great. Thank you.
All right. Well, thank you, everybody. We'll see you again soon. Well, that's another episode. Thanks for listening or watching the Reliability Matters podcast. Don't miss an episode. Subscribe to Reliability Matters on Apple Podcasts, Google Podcasts, Spotify, or virtually wherever you get your podcasts. A video version of this podcast is available on our Reliability Matters YouTube channel. Be sure and subscribe to that as well. A special thanks to Circuit Assembly Magazine's PCB Chat at pcbchat.com and Ascendo Reliability at reliability.fm for syndicating the show. Thanks for your questions and episode suggestions. Please keep them coming. Send comments to my email address, mike@mikeconrad.com. That's Conrad with a K. Once again, thanks for listening. Stay safe, stay healthy, stay happy, and keep doing it right.
Thanks for listening to the Reliability Matters podcast. Join us on the second and fourth Tuesday of each month for new episodes of Reliability Matters.